Alright, any questions till now?
No.
Alright, so factor analysis of the basics now. Let's talk about. So Steve, I've got a question for you. Right, the variables. Maximum number of factors that we can get?
The maximum?
Yeah, how many?
I guess not. No.
That's the maximum, right? I know about compressing a already compressed file. There is no compression happening, right?
Right.
So copy from compressing.
Okay.
Right. Factors is 50. Right. Factors 1. Right. So the number of factors is going to range from 1 to 50. Right. So that is also controlling the compression.
Right.
Also, Kiran, you give me advantages and disadvantages for going for higher factors and low number of factors.
The high factors is the problem.
What's the problem?
You said that it's a lossy compression, so you might bring a lot of information, which might be
Number of factors or low number of factors?
You go for high number of factors. Because every time you create a factor, you're losing some information. I mean, most of it.
No, other way around, Kiran. If I go for high number of factors, compression is lesser.
Again?
If I go for high number of factors, compression is lesser.
I understood it as, when you create a factor, you're losing some information. So each is, yeah.
Correct. So from variables to 48 factors, there's loss of information, right?
Yes, exactly.
From 50 variables to 2 factors, in which case do you think the loss of information is going to be higher?
No, in the other way, but yeah, but I think I understood the right way, but I was explaining it the wrong way, I think. Yeah, so factors, yeah, you've lost quite a bit of information.
No, I've lost information.
Okay.
Right? So, all right, I'll give you an example. If I have a one-to-one mapping between variables and factors, then there's practically no loss of information at all.
Yes, that many variables.
Yeah. On the other hand, I'm trying to map multiple variables onto the same factor, right? There's going to be loss of information.
Yeah, the wrong way. Okay. Yes.
So, So, what's the disadvantage of going for small number of factors? What's the advantage for both a small number of factors?
Advantage would be you can create a simpler model, I would think. Again, like you said, when using 50 with 2 factors, information.
So again, the pros and cons. I think everybody's clear about that. We all need to fit in a perfect balance towards how many variables I want post factor analysis, with how much loss of information I'm willing to withstand. Alright. Now factor analysis is also known as dimension reduction. Right? So it is known as a dimension reduction technique. Anyway, we call it dimension reduction. dimension. So if you do it on SPSS, it will come under the menu of dimension reduction. So dimension reduction, Malik.
Ideal variable is nothing but the dimension which we can check.
Yeah.
Consider.
Perfect answer. Right. Can you try and explain it to the others?
Yeah, well, visualizing the data, that's the data set, we normally have numbers would define the dimensions. So in the we read the number of directions representing the data. Is that correct?
You're close, you're correct. For example, so Siddharth, have variables. So therefore, can represent the data set into a three-dimensional axis. Data set is nothing but a scatter diagram in the three-dimensional plane, or sorry, three-dimensional space. Now, I tell you that X and Y are highly correlated. Can I from labels to two parts? Yes, right? So this becomes essentially variables to two factors. My data is now represented on, let's say, one side, factor the other side. Data set as a down on it, right? Yes. Right. The data from a three-dimensional space, I'm now renting it on a two-dimensional space. Yeah. Right. Right. So I mentioned of the data set, right? So this is known as dimension reduction. So is that what you were also explaining? Yeah, Steve, is that clear? Why is it called dimension reduction?
Yes.
Perfect. Now, how do we actually go about doing it? Right? Quickly, on which kind of data set will this give us best results? So, Steve, what kind will give us best results for factor analysis? To do factor analysis.
Your relationship?
It will be a relationship anyway. What kind of data sets will you be, should you go ahead with factor analysis, or what kind of data sets would you avoid doing a factor analysis?
More continuous data?
Well, for starters, this can only be done on continuous variables. It cannot be done on categoric variables.
But can you categorical into dummy and then do it?
You can do it, but that's again a violation. But you can do it.
Okay.
Violate the assumptions and bring categoric variables relation also using dummy variables.
Okay.
Right? In this way as well. What kind of data set will give us best results on this, though? Any idea?
I'm not certain.
Right, so I'll give you an example. I got a data set with 50 variables again, Steve. Right? All of these variables are perfectly independent of each other.
Okay.
What does that mean? When I say perfectly independent of each other?
A change in one doesn't affect the change in the other.
Right, interdependency, can I say that?
Sure.
Right? In that case, if I go ahead and do factor analysis, what will happen? Is this really comparable?
Yeah, but it wouldn't be.
I'll never be able to get, yeah, there's a relation, so I'll never be able to compress more than one variable onto a factor.
Correct.
A variable will have one factor, and one factor will only be able to, explain one variable at a time. That's it.
Right.
Right? On the other, I've got a data set which has got high levels of linear interdependencies. Right? Lots of collinearity amongst the variables. In that case, factor analysis will give us best results. So, at the end of factor analysis, the factors are 90 degrees with each other, so they are orthogonal to each other. Right? So, factors have correlations with each other. So, the relation are factor 1 and will be equal to 0. When we do factor analysis, the end result, the factors that I get, completely uncorrelated from each other. Right? So I use it for. So now, what kind of data set we should be doing factor analysis for? Right? When we have continuous variables. Secondly, when these continuous variables have high amounts of linear interdependency. Right? So why do factors at all?
You mentioned that.
Yeah.
And then information getting
Where
using redundant information, obviously it's going to speed up your creation is easier. I mean, you're doing it on much lesser number of actions, and it's faster execution too. I mean, once you create it. Yeah.
Association with the variable.
So that I do it from a modeling point of view, right?
Yes.
That I'm factor analysis, and I'm going to use sort of factor analysis as an input for analysis.
Yeah.
We are doing it as an intermediate technique. So not a means to an end itself, it's simply a means to a further end. Why does factor analysis just for factor analysis? Because that's no technique which gives any kind of result typically. Right?
Then you can build a model out of that. Yeah.
The factors as independent variables, and it also solves the problem of collinearity. Right? I'm a model and there's a high amount of collinearity in the data set. Right? And solve the problem of collinearity. Instead of building it on variables, I can now build it on the factors.
Okay.
Right?
So before every regression model, or try
not every regression model. Which kind of when to
just take
multiple
regression
as well.
Yeah.
Yeah, for regression, but I won't do it on all data sets. I'll do it only on the data sets which show high amount of what?
Linearity.
Collinearity, right? If could call when I after analysis, Kiran, I lose information.
It's true.
So I don't want to lose information just for the heck of it, right? I only do that when there is no way around it.
Yeah.
The advantages of factor analysis over disadvantage. Malik, you gave a second advantage. What was that? Second reason?
Find reasons with the variables. Like
I do it from an exploratory point of view.
Correct.
Then I want to find out what are the underlying, associations within variables?
Yes. Uh, we have
variable. Doing factor analysis to get the factor result, but just to study the interrelationships between the variables. In that case, I'm doing factor analysis as a data understanding exercise, right? As a data exercise. So let's do factor analysis now. Please remember, factor analysis is probably one of the easiest things you'll ever do. Right? It's a simple, 3 or 4 step process. It's something on which you cannot go wrong. It is one of the easiest things you'll ever do when you're doing any kind of analysis. SAS is, let me see if it's working. No. Your screen. Import the telecom data set because it has a lot of we'll work with that first. Alright, data set imported. Alright, let's go to the code. Right, proc factor data equal to data set name. Yeah, name. Now, and specify how to do factor analysis. So copy and paste on the continuous variables. Do the categoric variables or the churn variable as well. So we avoid the churn variable for now. Copy the variable names from the data dictionary. So it will be Excel file. There. Dictionary. You don't want to take the you want to give education and scat later turn as well. Yeah. We don't delete education. Paste it. Education. Yes.
Those because
they are continuous in nature. Sorry, categoric in nature. They're categoric in nature.
But
setting the dummy variables in. Yeah. So we're setting the dummy variables in for now. We'll see how that goes.
These are categorical variables, so I'm just
variables in. They're these dummies, so we're letting them in.
Okay. And one.
So I should have it, but
Binary,
typically in analytics we go ahead and do it. So statistically it will be frowned upon, but we still go ahead and do it. Semicolon and run. Yeah. Let's have a look at and this output step by step. Now let's look. The first table you will get is the eigenvalue table. So variables have we put into our factor analysis. So Kiran, can you quickly tell me how many variables we input? So factors are possible? 30 factors, right? So this is giving us the values against each other 38. Kind of table, what are values or what is the analysis being done over here? Can you just scroll up? right? The variable that we get is the eigenvalue. Right? Now, factor analysis does is in the back end, right? It's all the variables. So, what do we mean by standardization of variables? Standardized, what does that mean? Okay, Steve, variable, variabilization. Two.
I'm not recalling. Sorry.
Object
X minus
transformation.
mu divided by sigma.
Z,
X minus mu by sigma. Anybody remember?
Yes.
so,
Yes.
right?
To Z scores.
Yeah.
Right. So when I change it to Z scores, what does the mean and standard deviation become? Standard deviation of 1. So that means every variable has got a variance of how much, Steve? Steve? Right? When I convert variables, so now you remember x minus mu divided by the standard deviation of the variable. Right? Convert variables values into its standard values such that mean becomes 0 and standard deviation becomes 1. Alright? So what variance of variable?
1 squared, so it'd be 1 as well.
It will be 1, right? So I have tables in the data set. Standardization, what's the total variance in the data set?
Yeah.
I'll rephrase the question. I've got 10 variables in the data set which I want to factor. Alright? So basically, proceed with the factors. I standardize the variables. And what is the total variance in the data set after standardization?
Would be 1.
It is 10. Alright? We've got 10 variables, so I need to explain the variance of 10 in the data set. So copy paste this table. Yeah, just need to Excel. Just of the eigenvalue table, eigenvalue column. You can stop any just sum it up.
Yeah.
Everybody can see.
Four. Increase the number of variables.
Variables which I have put into my factor analysis and my sum of eigenvalues. Let's do it again.
But there's 4 or 0. That's why.
Alright, is that? Just go back. Show me the telecom sheet. You just the telecom tab.
Log and
Log and all.
just log
Scroll to the right hand
columns.
side.
Yeah, these 4 we got to use. Remove those.
Alright, these variables were not included, so remove these from the code.
Go to log wire. Okay.
Run it again. Paste it in. We've got 34 variables and the sum of the eigenvalues is exactly 34. Right? So what is actually telling us is eigenvalues is nothing but the weight explained by each factor individually of the total data set. Alright, so again, a total variance of 34 to explain right? How factor explaining?
34 as a
Percentage is being explained.
23.
Do it correctly. Equal to B6 divided by right? The 4 decimal digits. You need to lock it correctly. Decimal digits. Yeah. Proportion column. So sir, can you explain the proportion column now?
So the variance explained each variable.
Of the total data set, right? Can you convert into percentage? Decimal digits. Now, what it's saying us is, factor number 3 is explaining 10% of the data set. Factor 2 is explaining 17% of the data set. Factor number 8 is explaining 2.96% of the data set. All right. Are you there?
Yeah.
All right. So if I pick up the first 3 factors, what percentage of the data set is getting explained?
About 52, 53.
52. So the cumulative is nothing but the summation of the individual variances explained to that particular time factor, right, Steve? If I go from 34 variables to 3 variables, what is
The loss would be 31.
47%.
Okay, yeah.
Right, what percentage is because it's going to be different in each, right? So go up to, let's say, 4 variables, I'll get about 60% explained, or I'll lose about 42% of the information. Right, Steve? At this eigenvalue table, can you tell me the optimum number of factors we need to go in for?
Can't.
Yes, Steve. Take a guess. How much enough?
90 or 95%.
95%. Have you R square of 95?
No.
So Steve, what's the R square? If you remember, we're talking. So, do you remember the definition of R square, Steve? The official definition of R square?
The codetermination, it's how much of variance is explained by your model.
Of the dependent variable explained by the independent variable.
Right.
Percentage variance. Right. Can I say the cumulative is the R square of factor analysis? Even not called that way, can I say it is analogous?
Think you can?
Right. Can call it, but typically it's not referred to that way. But it's also variance explained, right? Can I say that when I go from variables to 5 factors, the variance explained is 63%, or R square is around 63%. Right? Call it R square though. So Kiran, so don't call it R square because it's not called as R square. but it is do that,
Yeah.
right? Taking the
Yeah.
dependent variable, what percentage variance of the dependent variable is considered to be a good model? So, considered to be a good model.
Squared in terms of correlation.
Yeah.
Yeah, anything about 0.7 is great.
Is great, right? So typically, over here as well, anything above 70-75% is considered to be good. Right? So now certain rules that we can apply while trading the optimum number of factors. One rule which is applied most often is known as the min eigen criteria. That is the minimum eigen criteria. What it tells us, it says simply as many factors that have eigen value greater than 1. Right? How many factors eigen values greater than 1?
State.
Yes, Siddharth?
I think it's first state if
Siddharth?
the data is. Yes, Karan, can you hear?
8 factors, right? So I should go.
Yeah.
So I should go in for 8 factors, right?
Yeah.
8 factors. What is the loss?
For the first state, loan 26.3%.
26, perfect. Right? Now, question for you,
Sir.
Malik.
Yes, sir.
Yeah, one as the cutoff. 1.5 or 0.5. Why does eigen criteria say take 1 as the cutoff and extract as many factors which are eigen greater than 1?
Sorry. Standard deviation of 1, that's what we consider. So, standard of 1.
That's the reason. That's close, but you've not given me the reason. You've given me the point, but not the reason. Yes, but why not the reason? Anybody?
The this one, if it is less than that.
The bell curve.
No, not that one. Not that.
No bell curve. Kiran, cutoff?
Well, it seems kind of arbitrary still for me.
It's not.
Because
There's only one as the cutoff.
I was just going through some brief real factors, and said taking as a cutoff might necessarily be good all the time.
Yeah.
But
So
quite
there's no
different.
hard and fast rule to any particular thing. But my question is, why has one been, recommended as a cutoff at all?
Just trying to think.
Steve? Or what's the variance of a variable here?
What's the variance of which variable? One.
It's 1.
Right.
Now, so if a factor has an eigenvalue of less than 1, what does that imply?
That's the one standard deviation from the mean.
No, that's not. Variable cannot be different away from the mean. Right? What is that out of the total data set, it is explaining less than 1 eigenvalue, or it's explained by a particular factor of the original data set is less than 1. Right? If I extract a factor with variance less than with eigenvalue less than 1, my total increases by 1, right?
Would.
right? But does increase in factors justify its exclusion? Sorry.
No, it wouldn't.
Right. So what I'm trying to get over here is the cost benefit, of including that factor. When I include that factor, my compression is getting hit, right? I'm not compressing as much as I should be.
Right.
Right. So if I include a factor, it's to the table more than its own weight. What I'm saying is a factor with eigenvalue less than 1 is actually not pulling its own weight.
Right.
It makes no sense for me to extract that factor when data compression is the only thing I'm talking about. For example, I say 800 KB file, I compressed it, it became 900 KB. Does that make sense to you?
No.
No. Okay, let's extract factor number 13. Right? Factor is one full variable.
Yeah.
Value of against factor 13 is how much? This factor is about 60% of one variable.
Right.
Right? Increase my final list of variables by 1, but only bringing 60% of an original variable's information with it.
Right.
My cost benefit analysis to get 13 out, right?
Correct.
Right. So at what point does the cost benefit analysis step over?
At 1.
At 1, right? So I can keep extracting till 1. The minute it falls below 1, I can stop. Right. So that's typically the reasoning, given that why we should extract factors till the median value of 1. Kiran, is that clear?
Okay.
Right. On the other hand, I also want to give a loss of information, right, Kiran?
Yes.
Sometimes it will happen that if I go by min eigen, my cumulative has only reached 55 or 60%. In that case, will you do?
You have to
Another
include
eigenvalue
more than
table.
that. Divide the Boolean go less than 1 and see how far you go in terms.
Okay. So typically it is recommended that you capture at least 65 to 70 irrespective of the eigenvalue.
Okay.
Right. So what we do is we look at a combination of the cost, benefit, and the loss of information and eigenvalue at the same time and come to a conclusion. Over if I use min eigen, I'm getting 73%, right?
So quick question for you. Quick question.
Yeah.
So eigenvalue is less than 1 here, starting from variable 9. It's 2.84%. I mean, should we look at the variance explained? Should go all the way down to
total data set.
What?
That's 2.8% of the original data set. When E itself is bringing in about 3%. If I have 34 variables, variable by itself is explaining 3%, right?
Yeah.
Right. 2.8% is less than the value of a variable.
Okay. Yeah.
Right. So that's why you need to look at the eigenvalue, raw eigenvalue itself.
Okay.
All right. And so again, the number of factors to be extracted is not a hard and fast rule. All right. Depends on what is you're going to use these variables for. For example, supposing I want to do a logistic model on this, right? So from variables I'm going down to 8 or 9 variables. That's very good, right? About 27%. Right? Supposing I say no, we have to go up till 80%. That means you will go up till 11 factors irrespective.
Yes.
So I can variety of techniques. I can use the min eigen criteria. right? I can goal in mind. So for example, I say 85% is the minimum that we have to go. In that, you will extract till 14 factors irrespective of the eigenvalue.
Okay.
Right? I want to extract up to 70%. So how many factors am I extracting then?
But
Let's code. All right. On the proc factor statement itself, the semicolon equal to n for equal. Let's give it 9. Out to is equal to data set name. Variable.
okay.
You know it's a factor. Yes. Execute.
Instead of telling any factors to just say do value and anything less than 1. Is there a
You can give the main eigen criteria, but typically you have to give n factors equal to,
I see.
right? You can try it out, the n factors equal to main eigen. So, or you would just give an error, say n factor criteria is required.
Okay.
If you without n factors, it will give you an error.
Okay.
Execute this.
It's running. Didn't.
I mean,
Yes. What is it doing?
if it's already open in your, is the data set open in Excel? Kevin,
Uh,
it's open. So close it, don't save it. No, don't save it.
oh.
You know. Close this.
Why don't
And
we
create
just-
this, recreate CSV from the original file. Create this CSV. That's all right. Good data. Yeah, to the extreme right side. I hope you've got no variable over there. Can you do thing? Can you just replace it? Just cancel this. Select AM. Yeah. Select A to AM. No. Go here. AM.
yourself.
With control. Replace with 0. Yeah. Same thing that you did. Click on AJ to AM. Click. Go all the way up. It will stop every time. Use page up. Okay, use page up and
Yeah, I
click
did that.
it. Just jump up.
0. Control.
Control it. That's it. Then replace with 0. Now save this as a CSV file. side and import it. And close it before you do an import. Close it. Please import. Run the n factors equal to option. Alright, Andy, we've got SAS running on your system. Can you share your screen?
On the computer webinar on. Separate.
No. Okay. So here variables here in which we deleted. Already let it be.
Yes.
Really for now. Already executed it, right? That's all. Do it
No,
with
not
those
yet,
34
not yet.
variables for now.
So importing the data.
Okay. All right. Factor first without the output out statement or end factor statement. So we look at the eigenvalue table once more. Just yeah, run it.
So
So 9 how much now?
70.
So let's go with 9 factors itself. 9 out and common for factor 9. Yeah, execute this. Write up the data set. The output data set for now. Data set. So let's right hand side. So what do we see? Leave Siddharth, just open the output data set of your Proc factor state output data set which it reads. In the right hand side, what would you see? Yeah, done?
Same.
Okay. See, done?
Yeah.
Are you seeing factors in your data set? Yeah, Steve, I didn't get your answer.
Yeah, I'm getting them.
All right. What I want you to do is means only on the factors and find out the mean and standard deviation. So
Yeah.
this is the code of the chart window for now. Also, Proc means write the data set. Right, Proc data equal to data set name. Factor data set, the data set which has the factor. And right, don't run it like this. Here's that. So we're only for the factors, right? Factor one, factor 9, dash, not all right, not dot dot, dash, factor 9, not 9.
Yeah.
The full name, factor 9, semicolon. Yeah. Right, so what's the mean coming out to be?
Pretty close. Basically.
Okay, space is 0, right? And standard deviation? 1. Right, Steve, same result?
Here, I'm rerunning it.
Alright, Siddharth, have you managed to do the Proc factor? Or your SAS is too slow?
I just imported a data set. So
The code input, copy paste the code from the chat into a notepad in the meanwhile, so you don't lose the code. Kiran, in the meanwhile, run a correlation matrix on the factors. Same way.
Is it sensitive?
Run it. What does the matrix look like?
Oh,
Independent of each other,
yeah.
right? So all factors are perfectly independent of each other, right? It's called Malik. What called?
Yes, Karan.
What is called where the data and all the other all points are 0. What is this kind of a matrix called?
Identity matrix.
Identity matrix. Perfect. So
Yeah.
the correlation matrix between the factors will approach an identity matrix.
Yes.
All right.
But I would like to ask how evenly is calculated. Normally it's the factor, right?
Due to matrix multiplication itself. So values are nothing but out of the middle where variation. So I think sort of echo. Yeah. So for each of the factors is a measure of. So measure that each factor is explaining out of this how much is that a factor able to explain the original data set, right? So for example, if I get an eigenvalue of 8, right? If the total variance in the data set is, let's say, 32, that means that is explaining 25% of the original data set itself. Right? 20% of the variables are so correlated with each other, they are actually loading onto one particular factor itself. Right? Yeah, Malik? What can actually derive from it is, this is also known as the information that a particular data set has got into it, right? So, say eigenvalue is a measure of the information being coded into the particular variable. Alright, now is we're going to break this class into two parts. Tomorrow I'm going to continue with factor analysis, but there's one side that I want you to do right now. Alright, are you there? What I want you to do is, so we're done with factor analysis as of now, so there's still a lot of part in the factor analysis output that we'll cover tomorrow. Tomorrow's class, what I want all of you to do is factor telecom data set as well as the Charles Book Club data set, the independent variables alone. Visualization, I want you to split the data set into training and validation. Okay. Based only on the training factor, right? The score of the validation data set, and I want you to compare the drop in performance visible on full data set. Then the model built only on the factors tested on data set, right?
Okay.
Explain it again. Telecom set, right? The full observations, factorize it, create the 9 factors. Validation, right? A model using all variables. The next model using only the factors.
Okay.
Score models on the validation data set and the case.
And will validation have validation data sets? One with all variables, one with
create only validation data set. Right? I did it again. Factor data set, split it into training and validation.
Okay, data set will have the variables along with the 9 columns of factors.
The 9 factors, right? So training and validation data set will have the same the right? But now what you to do is on the training data set, build a model using all variables.
Okay.
Right? Then second model only the factors. So first model you will use only the original variables, not the factors. In the other model you use only the factors and not the variables.
Okay.
You will have 2 models.
Right.
Upload the models on the validation data set and generate the KS for the variable model and as well as for the factor model and tell me the KS. Cover both the 2 models.
Okay.
Alright. Or if you say that variable model has got a KS of 35, another model has got a KS of 32. Right? That there is a drop in performance when I switch over from variables to factors.
Right.
Here, and this with 9 and go up to about 85% as well. So okay. Increasing the number of factors improves the model performance or not. Alright, so can you just make a note of it? I'll just make a note of it and I'll mail it across what I want you to do. I will replicate the same for the Charles Book Club as well.
Okay.
Alright, book club data set as well, create the factors, compare the performance of the original variables with the factor and generate the KS. The key value has to be calculated on the validation data set. I am not interested in the training performance. Alright?
Okay.
Yeah.
I got it.
Anything else? Alright, so we'll reconvene in tomorrow same time continue with factor analysis. In the meanwhile, what I want you to do, if you can send me the results of these exercises by tomorrow, right? Go over and we'll also discuss that how much does a performance actually suffer when I switch from building a model with all variables to a model with only factors. All right, do not make a model with both variables and factors. That makes no sense.
Okay.
Okay.
Especially for the training one, right?
Yeah.
But when you have both variable and factor in the same one.
No, I'm not building a model.
Okay. Yeah, modeling is just on the training. Okay.
Yeah. Two models, one on variables, one on factors. Don't which has got both variables and factors in the model statement.
Yeah, that. Okay.
All right. See what needs to be done.
A stupid question. What type of model are we supposed to create? Thank you.
Clear? Right. Excuse me. I'll send off a note immediately, and what needs to be done, and what I'm looking at is SAS to be calculated for both the factor as well as the original variable model. We had to cut the class, 30 minutes short, but I think, probably it's best that we cut short the class now so that I don't tax my throat too much. I'll continue with tomorrow's session. Again, there's an overflow of factor analysis. So typically take 1 more hour. For factor, then we'll touch upon cluster analysis. So we might have to, the schedule which I've sent across, do 1 more day on that. All right. Any issues?
No issues.
All right. So again, I'll quickly send across a mail in the next 5 minutes. Any doubts, queries, you can just revert on that. So that mail should make it clear what needs to be done.
Okay.
Right. Thank you, guys.
Can you send the code once?